Hello everyone, I am Rahul Shandilya, and in this new lecture of Internet of Things we will discuss another device, uh, Raspberry Pi, which is a single board computer and become very popular for the IoT system. So what is Raspberry Pi? In fact, the Raspberry Pi was developed just for hobby electronics or just to make school kids interested in the electronics and computer science. But is very cheap, and that's why it become very popular while designing the IoT system. It is also very um, capable. So the Raspberry Pi is a very cheap computer that runs Linux, but it's also provide the set of GPIO. What is GPIO? We have already get its meaning in the previous lecture. That is general purpose input pins that allow you to control electronic components from physical computing and explore the Internet of Things. Raspberry Pi is used to learn programming skill, build hardware project, do home automation and industrial applications. So uh, just it was begin just as a purpose for learning programming skill and have interest in hobby electronics. Now it is become so popular that it is also used in industrial along with the other technology, of course. So here we can see in this picture a single board computer having all the important devices that is used, that is attached in a full-fledged computer. We have USB, we have Ethernet connection, we have RAM. Raspberry Pi 4 has option of RAM up to 8 GB. It is Pi 3, and we can see here also we have option of 1 GB, 2 GB, or 4 GB. So processor almost powerful as your laptop process. Now we have micro HDMI port to connect video and audio devices. So in fact, it is a single board full-fledged computer. You can connect your screen and you can connect keyboard, and you have all the full-fledged computer. But in this lecture, and particularly for us, it is a single board computer uh, we use as a gateway or edge computing devices in our IoT system. So in this diagram, we can see the main component of the Raspberry Pi. Here it is Ethernet connection. Uh, Here it is Ethernet connection. Then we have two USB and stereo audio port, HDMI for audio video connection, and also there is a power supply, micro SD card, 40 pin. So these are the main components. Apart from HDMI port, there is also one stereo audio port. And this is the pin diagrams of Raspberry Pi. We can see we have 40 pin, and we have all the pins, that all the important pins that we have seen on Arduino board. Like we have say PWM pin, pulse width modulation pin. Then we have SDA SCL used for SPI communication. That means communication for the chips. And then we have again a receiver transmitter somewhere. Yeah, and MOSI MISO that is needed for SDA SCL for I2C and MOSI MISO for SPI communication. So we have all the important communication, and receiver transmitter we have RS232 communication. So this pin in fact enables you to connect with different electronic components. Its pin enables you to connect with a microcontroller, and we have Ethernet, Wi-Fi enabled, so it is directly connected to the say your main internet. You need not to put another component. It has all the component on the board. This is another version of Raspberry Pi. It is a small, that is Pi Zero. Means now we have also Pi Zero W. Means Pi Zero is a very small. We have RAM up to 500 mega in 500 megahertz range, and we have Wi-Fi also now. That is the Raspberry Pi Zero W version. We can see in this picture, in this table, different versions of the Raspberry Pi, uh, and we can see compare. It is as price. If we see the price, it is very cheap. Means Pi Zero come in just $5. Means even a $5, you can get it in say 700, 800 range. And so its price is very less, and that's why it is popular among the college students or even school students. And we can see the processor. Yeah. CPU 1.2 gigahertz, 1 gigahertz, 900, 700 megahertz. So Pi Zero has 1 gigahertz processor, and this is 1.2 gigahertz. Now it Pi 3, Pi 4 is in fact 2.4 gigahertz range. So now Raspberry Pi important connectors, and these connectors are GPIO header. GPIO stands for General Purpose Input Output, which has been brought out pin connectors present on the board. We can read values from any other peripherals such as sensors and computer. The receive value in your own programs. Apart from reading the value, we can show the result of the program by connecting LEDs or embedded LCD displays to the board. Depending on the decision taken on the code, we can drive the motor connected to the GPIO through motor drive. So GPIO, we have already seen in Arduino, is a general purpose input output pins. We can connect various sensors. We can then enable the modes, that is whether this pin is, that is pins serve as both input and output, as the name says. uh, the difference was, if you want to take the difference between Arduino and say Raspberry Pi. Arduino has 6 analogs, while it has only one. So basically Arduino is more suitable to connect directly analog sensors. But if your sensor is mains based or have SPI I2C connection protocol, you can it is better to connect with Raspberry Pi directly. RCVideo output. Mainly Raspberry Pi is used for computing device, means it acts a gateway device, and microcontroller is an end node device connecting directly to the sensors. So remember, Raspberry Pi is for gateway or edge device, means if you have to carry out some computation at edge level, we will use Raspberry Pi for, because its processing, as we have seen, is much more. It can process audio, and even it can process your audio, images. We cannot process image on the microcontroller. So RCVideo, though microcontroller also comes in 32-bit now and has a considerably improved computing power, but still it is designed for mainly the sensors data. RCVideo output. RCVideo output means it carries video signal, which is type of the Raspberry Pi RC connector or composite video signal. Is merged with 3.5 audio jack on Raspberry Pi. So this is the important. USB, most common connector. We know what USB do. Through USB, we can also connect Wi-Fi dongles, Raspberry. You can also connect external power USB hub, Raspberry Pi to connect it. Ethernet connections, this is one of the most important connections to have remote login on the Raspberry Pi, provide wired internet connections. You cannot always connect Raspberry Pi to the dedicated display. In fact, you can program it without display and without keyboard, but just by logging in from the another computer. For that, Ethernet is used or Wi-Fi is used. CSI camera connector. The Raspberry Pi board does not come with the camera module integrated, but a separately brought camera module can be interfaced using CSI connector via a 15-meter flex cable. 5 megapixel Raspberry Pi camera module can be used to record high definition videos as well as photographs. This camera module provides improved performance over the USB connected camera. HDMI connector ports. We know HDMI stands for High Definition Multimedia Interface. Is a compact audio video interface used to transfer uncompressed media data. You can connect your modern HDTV to watch full high definition videos through the S. So uh, you can see uh, in what various purposes your Raspberry Pi board can be used. In fact, it can be used uh, as a server, although a server computer, but in a limited form. Of course, it has a very less bandwidth, and in service, a server computer, we need high bandwidth. If you plug HDMI connector, there is no need to connect the speakers to audio. It can be used as a computing device. If you assemble multiple Raspberry Pi and enable parallel computer, you can uh, use a sort of, say, SPC cluster. There is no need to connect to the speakers to the audio jack, and you want to sound both HDMI and HDMI. Micro USB connector, USB connector is an important one. SD cards also, and this is important because Raspberry Pi has internal memory, but it do not have any hard disks. So we have from to in the main means your OS and your programs and everything is stored on the SD card, and it has slot for the SD card. Just so you have to put SD card externally, and which costs you another 200 to 300. So just you put this cost on your Raspberry Pi. Display connector. Last but not least, the display connector used to connect 7-inch finger display. So there is also one, apart from the HDMI port, there is also a display connector. Raspberry Pi has 7-inch say LCD display that can be used for various purposes, like so the status of your sensors or everything, and you can connect it say you can connect it or disconnect it. So if you have deployed Raspberry Pi anywhere, you can simply, and you want to say, read the status, and it is deployed not to the internet, you can just connect this display and have a small keyboard and have all the facilities of computer. So application of Raspberry Pi. The Raspberry Pi as an edge device. As I have said, the Raspberry Pi is very suitable for the edge computing. Uh, the Raspberry Pi, because we can directly connect internet through it. We can say, through Wi-Fi and Ethernet. Also, we can. It has so much computing power that we can enable or we can perform any the internet protocol smoothly is enabled on these devices. So the Raspberry Pi is the most common used edge devices for building IoT solutions. The affordable price and accessibility is something important. The computing and storage capability of Raspberry Pi enables people to use it as an edge devices within the IoT project they are building. Also, both Raspberry Pi models can directly be connected to the sensors and actuator pins through pins, as we have seen in the GPIO pin diagram. The devices can support also basic GPIO, SPIO, I2C serial connector. So at one side, we can connect internet uh, easily, and on another side, there is also connection for I2C, SPI, and RS232. That means your sensors can be indirectly connected to the internet. So it has found application in both commercial and industrial. In fact, Raspberry Pi customized its board for industrial application also. Raspberry Pi in industry. A fundamental characteristics of any industrial system is the need to respond in real time to specific triggers. As already mentioned, industrial devices need to be robust and to work uninterrupted for long periods of times in harsh conditions. If or when they fail, IoT devices need to able to reset, recover automatically, or as in the case of catastrophic failures, send diagnosis information to the main system. This is why most of the industrial systems are built on PLC. PLC, which is compatible with the Raspberry Pi, exists enabling integration. So, as far as industry is concerned, the most popular computing device is the PLC because it is real time. Uh, it has very almost negligible instantly computed, and it is harsh and rugged. Means it's a rugged device uh, that can sustain, that can work in harsh environment for long time. And in industry, we have high temperature, we have humidity, and all this. But PLC provide real-time computer, but has less flexibility because it is not general purpose computing device. It enables just ladder logics and perform some say switching on off for various numerous motors instantly. So it is connected with the Raspberry Pi so that these devices can directly now become a full-fledged computer and can be connected to the industry. And in this way, Raspberry Pi provides multiple purpose use in the industry. While we cannot use the real-time computing, we cannot replace the PLC with the Raspberry Pi because it needed very fast computing. But along with PLC, Raspberry Pi provide other functionality. For example, through it we can see the proper functioning of your devices. You can monitor the health of your devices, industrial component, and we can provide some say uh, control. We can also load PLC's program through it. So you can here see the Raspberry Pi purpose as a edge devices. We have sensors and sensors are directly, if the sensors is powerful, means advanced, you will have I2C or SPI connection directly connected to the Raspberry Pi, or it is if you have multiple sensors, it is better to connect with the microcontroller, and that microcontroller can be connected with Raspberry Pi. So the microcontroller and node and the Raspberry Pi provide the gate. With this, we end our lectures, and in another lecture we will in throughout our courses we will I will show you various applications of the Raspberry Pi, various programs. This is just the introduction of the devices.